So as you can tell, my name is William Cannon, and today I'm going to talk about how to achieve a highly available SaltStack implementation. Before I get started, if I could just get a show of hands, who here has used the Salt Reactor? Okay, and who's written a Salt Runner? Okay, same guys. Anybody run a multi-master configuration? Okay, same guys. Anybody use AWS? Okay, so that's good to know. Okay, so who am I? Well, I am a SaltStack certified engineer from SaltConf 2014, so last year, cool conference. I'm a co-founder in a small startup dealing with hotel room optimization for assignment. Got a background in chemistry, computer science. Python's my language of choice, and to be quite honest, SaltStack is my platform of choice for solving things that need to get done. And believe it or not, the weather here is just great. I live in Minneapolis, and it's -5 degrees is the low today, so this is just really comfortable and nice. Before I get started, I think I'll let you have a little info about my background, just telling you 1 or 2 projects I've done with SaltStack, so you know that it's not my first rodeo with SaltStack. The first real project I had was a consulting project from Machine Zone, which, if you know gaming companies, is one of the big mobile gamers. And they essentially wanted a white hat botnet that could tell them when their game's going to break. And they came to us and they said, we have all the software we need to manipulate the game, but we really need to be able to instantiate anywhere from like a dozen to 1,000 servers within, let's say, 10 minutes, load all of our software, test the heck out of it, monitor it for some reason, and be able to shut it down in 1 hour. And I said, oh, okay, well, that's normal. Everybody does that. And so I chose 2 things to use to base this on. One was Boto. CloudFormation wasn't around at that time, so I had to write something that would spin that up. And then SaltStack. And SaltStack was really a big selling point. This company at first said, why are you putting this big software in for us? And now, I don't know if they want me to say it or not, but they use SaltStack for their deployment. And they use it for a lot of different pieces of their infrastructure. But it was very nice to be able to make a custom module, distribute it to 1,000 servers and in a meeting and execute that and have them say, okay, but how long would it take to do really? Say, okay, well, we just did it. So that was the first time where I said, okay, I'm going in deep with this stuff. This is great technology. Which leads me to the second project I did. This was for Jabil, which spun this off into a separate company called Stack Velocity. Essentially, they wanted to be able to sell racks of Hadoop clusters. And they wanted a way to do this that was very, very flexible. And they wanted to validate all their environments. So you can imagine setting up Hadoop and you know kind of where your servers are and what's going on. And you can kind of figure that out. But this project, really, you had to abstract that out and say, I can't really know how many servers I'm going to have. And I can't know if everything's really working. Somebody else is going to run some set of scripts and it's going to set things up. And so I used SaltStack for this, and it just worked like a charm. There was a lot of work to this project. I ended up using the overstate system and a lot of Salt runners, a lot of custom code, but I was able to do things like check that all the servers could connect to all the other servers on the ports they should be able to, and bring that back into this nice report on the fly, which is really great if you had a rack that wasn't communicating or some ports that weren't open that should be. So anyway, this was a really big success, and we could also say, hey, not only did we have the resources we needed, but these MapReduce jobs, they're working correctly. So that was a really cool project for SaltStack. Currently, I work for a little company called HospitalityPulse, and the first project I did for them was just a simple LAMP stack deployment project. And I ended up using the Salt file server, the Salt client, custom modules, runners, And I took what was a deployment of about 60 to 70 seconds and cut it down to 6 seconds. And we're still using that today. It's awesome. And because I'm using Salt, I was able to hand that off to the developers and say, yeah, don't bother me with deployment. You guys deploy when you want to deploy. And so everybody was ecstatic. And so this is in use today. Of course, it's been added. Now there's new modules that have the minions check themselves to see if their apps are running correctly and report that back as part of deployment, things like that. So now I'm going to give you a shameless plug. And the reason I'm going to do this is because my company not only let me come here and present what I've been working on, but they're letting me give this code back to the community. So I said, okay, I'll do a little plug and just say kind of what we do. Essentially, we handle this thing that sounds really easy, but is just a real pain in the butt for hotels. And this is room assignment. So a lot of you guys probably have hotel reservations, and you arrived and you thought, oh, when I made the reservation, that was when my room was assigned. But it wasn't. It was really assigned the day you arrived. And it wasn't really finalized until you walked up to that counter. And it's actually a really hard problem. It sounds really simple, but you have to consider, what somebody asked for in terms of beds or specific things like a view that they wanted, ocean view, things like that. Upgrading someone, downgrading someone, room cancellations. If a room is clean when you're checking in, we look into the future a couple weeks, and we try to optimize, exactly what you should get. And that makes the guest happier. It makes the hotel a lot happier because instead of looking when a guest comes in and says, okay, John Smith, I think this is the room for you. At any given moment, we optimize against all the guests, and we can say, at this moment in time, this is where John Smith should go. And so that actually saves the hotel front desk staff about 2-3 hours a day. So everybody's happy, and that's the end of all the plug. So now it's all SaltStack HA. Thanks for being patient. Okay, the motivation I have for SaltStack HA. Basically, we use SaltStack for everything, and we love it. Okay, it's this magical tool weapon. It's the unicorn that allows us to do everything. And it's super easy because I love Python, and I totally get how this stuff works. So it's just a Swiss Army knife for us. So config management, deployment, everything, pillars, custom modules, we're all in, okay? But we want to go a little further. We want to not have to worry about what the cornerstone of everything else is based on. What we want to do is have this environment that just takes care of itself. So, we don't have to worry, oh no, the Saltmaster crashed or there's an issue. What we really get is a notification, let's say, that a Saltmaster replaced itself. Oh, okay, that's not such a bad email to get, right? But having to go set something up again really stinks. So that's the challenge. Here's the caveats. We're totally an Amazon shop. So this talk is highly Amazon-based. We're a small company, so we're not supporting a bunch of OSs. We've got Ubuntu. And the SaltStack version we're using, 2014.7, anything that we're doing automation-wise, it's going to be AWS, Python, SaltStack. And that's it. That's really our problem domain. So before you can solve a problem, you have to define the problem. And this is a point of contention. A lot of people will have a lot of different opinions on what a highly available system is. I tried to think of what we need, not necessarily what something is specifically. A lot of people would set up 2 Saltmasters and say, okay, job done. I've got 2 Saltmasters, right? It's HA, which it completely is until the moment you lose one Saltmaster. And now you're one step away from a really bad day. So the problem is a little convoluted. So here's the definition, and here's kind of something that we're going to iterate over and over. These definitions, and then kind of pushing forward into the resources that are necessary to make this environment that we don't really have to worry about. So I don't want a single point of failure. By that, I either want a master that replaces himself, or I want several of these things. I don't want to have to do something. Okay, I think when I hear the word PagerDuty, I think of duty. I don't know about you guys, but that's not the kind of email or phone call I want. So I want this thing to recover without human interaction. I want something to detect something went wrong and just fix it for me. Okay, I don't believe in human automation where I have to go push buttons. If I can do that, I should be able to set up some logic to go push the buttons for me. And if I need some additional resources, I don't want to go ask for the resources. I just want them to magically appear. And this sounds like the unicorn, and maybe it is, but this is what I'm trying to do. So what does SaltStack say you have to have for multi-master? A couple of you are using it, so obviously you know, but quite honestly, it's fairly simple and straightforward. You've got this public-private key pair on the master, and any master that is working has to have the same key pair to work with the same minions. And that's just how it is. It's highly recommended that you keep your states and your pillars in sync between the masters. And for the minions, they need to know about the masters. So, okay, this is not too bad, but there's no built-in way for the masters to share information, quite honestly. Not really. Anything you do is going to be hacked on top. So these guys are independent. So let's talk about what we need to deal with. Well, the minion keys are not really shared at all. So each master has to deal with their own minion keys. You could share this directory, but I didn't go that route. And I'll tell you why. I'm a big scaredy cat. There could be some kind of weird race condition that nobody is hitting because not many people do this, and I don't want to be the guy that finds that bug. And it's not really built to run that way. So states aren't shared. Maybe we could use GitFS, or same thing for pillars, or put things in S3. But let's update the requirements knowing what we know now. Okay, so we need a service that monitors a master and replaces a master. It seems kind of obvious. We need some way so that whichever salt master comes up first or is replaced gets that same right key pair. Okay, doesn't sound too bad. We need to deal with minions that sort of arrive and go away. Odds are, if we're doing this, it's because we have minions that spin up or spin down, but we don't really want to deal with them. Again, this is in AWS, so obviously this is an auto-scaling group. And you don't really know a whole lot about these minions, and they might go away quickly. Minions have to know who their masters are. And that was an interesting problem. And we need a way to keep the state tree and pillars and whatnot in sync. So that I kind of covered a little bit. So the next slide has a big list that looks scary. These are all the components that I solved this with, but don't be scared. We'll go through them all. It's not that hard. So being AWS based, I'm using a lot of things from AWS. And then I'm combining the pieces that I can't cover from AWS by things that are built into SaltStack and recommended from SaltStack for exactly this kind of stuff. If you don't know, CloudFormation really is pretty slick. It's got its own kind of DSLE kind of thing, but essentially it's sort of like the state system plus Salt's orchestrate, and it allows things to come up in an expected way. And it's really slick, and so you can repeat things over and over. And so again, I don't want to do things by hand, so that's why I started there. Auto-scaling groups, that's nice. We're taking advantage of that everywhere. S3, you can think of that as sort of like golden buckets where you can put things that masters or minions can always get to and get information out of. Roles and profiles, that's not really obvious why I would do this. Maybe it is if you looked into this, but I don't want to deal with credentials on servers for getting things into or out of S3 or anything else. I essentially want to assign a role to a server and say, server one, you are allowed to go here, you can pull some stuff from over there, and you can't do anything else. And I don't have to deal with credential management or rolling keys or anything like that. That's built in from S3 and IAM. It's really slick. I'm using Route 53. specifically for the masters. And I'll go through all this. SNS for notifications, SQS, which will become obvious. And then the interesting thing for SaltStack is how I'm managing these keys on multiple masters and using reactors and runners to do so. So if you're paying attention, this has a lot of elements that sound like the EC2 Autoscale reactor. And it does. It's not. I was heavily influenced by this project, though. I thought it had a lot of really nice elements that we could take advantage of, but it wasn't exactly what I wanted. And if you don't know what the Autoscale reactor is, essentially, it's a very convenient way to use autoscaling in Amazon. And when servers are launched, meaning minions, a message is sent to your master, and he can manage those minion keys and then go and install Salt minion on the new server that conceivably doesn't have Salt and whatnot. And it handles all the key stuff. So it's really slick. So why wouldn't we use that? Because it sounds awesome, right? Well, it wasn't really made for the purpose of running to Salt masters. And it becomes obvious as soon as you dig into the code. So what it's doing is it gets this message about a new server, and it SSH, well, first it verifies that message came from Amazon, and then it uses Salt Cloud to go ahead and install the Salt minion. Handles the key minion management by preceding the key on the master. And that's great if there's only one master. I have some issues with this. Number one, now I have keys on just one master, and what if that master goes away? That's really a bad day for everybody. Another really big issue I had with this was that these SNS messages coming directly to SaltStack mean you have to make essentially a web server on your Salt master available and open to SNS, and that's not really easy to secure. You can get a list of all the IPs used by Amazon, and then you have to manage that, and it's not really clear if those are every server in Amazon or just all the services in Amazon, and it's just, I felt uncomfortable. I don't like any extra attack vector. What if there's a bug in Cherry Pie, right? It's a horrible day, and now they've compromised conceivably the server that will make my day the worst. So I didn't want to use that. Plus, maybe I don't want to install the Salt minion this way. If I'm in Amazon, which I am, I'm probably going to pre-bake a bunch of things to change the launch times to be very short. And certainly we can't address replacing a Salt master using this method. It handles the key management for minions very nicely, but it doesn't really address anything about the Salt master itself. Excuse me. And so what's the solution? So this is kind of obvious, I've said it. We're going to use all the AWS services we can, and whatever is lacking, we're going to make up with SaltStack. So here's a nice little description of what I'm using from each of the AWS components. CloudFormation to bring things up in a standard way, and you can just throw everything away. And that actually handles a lot of things. VPCs, IP addressing, subnetting, security groups. I mean, the list it's big. Autoscaling groups. You don't want to have to go launch a new Salt master by hand. That kind of defeats the purpose. I think most of these I talked about. So what I'm doing with SNS, so this is a little different. I'm taking autoscaling messages. Those are being published to a topic in SNS, but I'm using an SQS queue as an endpoint for those messages. And I'm doing this so that I can have a Salt master pull from SQS rather than opening this up to everybody. There's an additional benefit of this. If my Salt master is unavailable because, I don't know, it's rebooting, those messages aren't missed from SNS. They're sitting there in the queue when that guy comes up, and he can manage it and process it. And the last bit is Route 53. So I cheated. I don't really want to deal with a whole bunch of DNS names and crazy stuff. So guess what? I'm using CNAMEs, and the Salt masters, they just go and update the target in Route 53. So this way, the Salt minions, it's set on them, it's static, they know where they're going. I don't have to deal with that. So this is a lot of nice text, but as they say, a picture is worth 1,000 words. So here's a picture. So it's kind of obvious to see what's going on, but this is a separate group for Salt minions you can think that are sort of coming and going. And when they do, as I was saying, you get a message into SNS that populates into SQS. A SaltMaster process is coming over here and pulling from SQS, and then it's synchronizing data into S3, things like the public and private key, and also another file I'll tell you about in a second. And then SaltMaster is an intelligent little guy, and he's got another process that when this guy boots up or when he reboots, he goes ahead and updates what his CNAME value is in DNS, so the SaltMasters can find him. Because if you stop SaltMaster or when it's terminated and restarted, he's getting a new IP, he's getting a new DNS. So that covered the AWS components, and I'm going to go through things in a little more detail, but the next thing to cover is the custom components. So the stuff that we had to glue together to make this stuff work nicely. Essentially, there's a whole bunch of data. If we go back to this slide, this autoscaling group can pass a whole lot of data over to the SaltMaster when he comes up, like what region you're in, what queue name you should check, what's your DNS name that you're going to update yourself with, this kind of stuff. Because again, I don't want to hard code stuff if I don't have to. I want most of the stuff to be sort of shoved down to the SaltMaster. So that SaltMaster Bootstrap is really involved in that, and I'm going to go through what it does. The DNS Updater does just what you think it would do. There's a little startup script I have called AWS IM, and that really keeps track of all these minions that we expect to see, whose keys we'll accept, and whose keys we'll delete if we get a message about deleting. And then we have Salt Reactors and Salt Runners. So again, pictures are a lot easier than words. What the heck does this look like? This area, let's see if I can see this. This area here, if you can see where I'm drawing kind of circle, is all on one SaltMaster. And you can see this SaltMaster process, AWS IM, is getting things from SQS. He's managing a little file of expected minions, calling it a DB, but okay, it's a file. It's a YAML file. And one reason to do this is, when you say, hey, you've got a new server, that server doesn't really connect to you for a couple minutes. So there's this lag time where you need to be aware he's coming, but there's nothing to do with this guy. You got to wait. Average time I've found from anywhere from 3 to 9 minutes in AWS. So really you want something waiting. And so what happens is, in this scenario, well, let me back up a second, but you've got this EC2 that I'm calling out to. So I can take this instance ID out of an SNS message and figure out what the expected minion ID is going to be and put it into this file along with the instance ID. So that when the Salt minion, so this is that other autoscaling group, when this guy comes up, he's going to submit his key to the SaltMaster. So that's, again, this whole thing here. And we've got a reactor watching for that event. So we're pulling that off the event bus and saying, hey, this guy did a salt auth. Okay, well, I need to figure out what I should do. Well, that's a runner, I'm calling it a key manager. It gets called, and he references this minion DB file. So if he's not expected, nah, I just let it alone. Maybe somebody's doing something outside of this, right? So I don't want to, do something bad to that guy. So I just leave his key alone. He can't get to anything. Nobody can do anything with him. It's fine. But if he should be accepted, then I use the Salt key class. I accept his key. That's great. That's all that guy does. What happens after that is he's going to submit another event, maybe in a half a second, 1 second, 2 seconds, at some point, and say, essentially, I'm ready to do stuff. Well, we've got this kind of either a half-baked, no-baked, or fully baked new server that wants to do stuff for us. So obviously, the first thing we do is run a high state. So I'm actually calling this my little high state reactor who calls a high state manager. And there's some logic in that. And you can see this arrow goes back to this guy. So I'm going to walk through each of these custom things a little bit more and then move forward. So the SaltMaster Bootstrap, again, this is really taking parameters. It's running one time only, the first time SaltMaster boots up, and it's getting data about sort of what it's supposed to become. So what I'm doing right now is I'm taking a lot of parameters from the AWS Autoscaling, region, queue name, DNS name, things like this, and I've created this subdirectory under etc salt. and I'm calling it the HA directory because I needed some spot, and it seemed like nobody else has claimed it, so it's mine. Again, this master script is really just installing the salt master, the minions. I put some grains on the salt master, and I add some the salt master config along with the minion config. And I do this because I'm having the salt master salt itself, because I don't really want to put everything in some shell script. I mean, we all used to do that. It wasn't that much fun. So I have this guy salt himself. So he accepts his own key, he salts himself, and then he updates his DNS name so that people can find, minions can find him. And then he also, if he's a new guy, he creates this minions DB file. And if not, then he's going to download a minions DB file from S3, because maybe he's a salt master that got reincarnated. One died, this guy came back and was like, oh, okay, I'm supposed to be this DNS address, and here are the minions that I'm supposed to work with. Maybe some were launched while I was being recreated. I don't know. And the same thing happens with the S3 keys in the public-private key pair. I have that in a S3 bucket. So the way this works is, well, I put first in wins, but that's more for solution 2. Essentially, this guy, the first time, puts the keys up if they're not already there. If they are already there, he downloads them, because there's probably some minions that are working with this guy, with that key pair. And then he restarts himself. So this is a kind of really critical piece. The other things are fairly simple. You've got this DNS updater, and I put this slide up because I think it's a little unclear exactly how this works. DNS and Amazon is kind of interesting. They have this sort of split DNS resolution where if you look up a name in Route 53 from outside of Amazon, it gives you, an external IP address. But if you do that same dig or NS lookup from inside Amazon, it resolves to the internal IP address, which is perfect for us. So this allows me to put something like so solution 1, salt1 dot, and this is a domain I own, devopslogic.com. It'll resolve to this guy, which then turns into an internal IP address that the minions can access. So that works really, it's kind of slick. You can call it cheating. It doesn't really matter to me. It works, so I'm pretty happy with that. This is the script. This is a startup script for Ubuntu, and it'll respawn if it needs to. Essentially, this guy just checks the SQSQ. Funny phrase. He pulls in the info about what queue he's supposed to monitor, what region he should connect to. And so I'm using Boto to do this, obviously. And he's maintaining this minion DB file, and that's located under that etc salt HA directory. So he's obviously processing these SQSQ messages. If he fails, he doesn't delete the one. It repopulates automatically in SQS. So either he has another chance or another salt master gets it. And then whenever, this is still prototype mode. So whenever he updates that file, there's a chance that he may go away. So I push that file up into an S3 bucket. If you had 1,000 salt minions, you might want to change this. I don't. I have 20, 30, 50 servers at a time. It's not that big of an issue for me. A few extra S3 calls. It's really cheap, nice and highly durable. The other thing this guy does, he deletes a minion key from the salt master. So if I get a message, I don't need to wait like I would normally wait for an event. I can just get rid of that guy because I know Amazon Autoscaling said, this guy's gone. There's no reason for me to wait around. So I kind of change that strategy a little bit. So I named this for AWS Instance Management, but it's been pointed out to me that you could call it awesome. Bad joke. Okay, so the salt reactors are really simple, and everything is simple by design. So really, you've got this key manager. He catches salt auth messages, and so it's key accept from the minion, and a hijinc manager, and he catches the salt key. So these tags are a little strange. I didn't make the tags. These are in salt. That's just what you have to use, and these are directly how salt says to do it. So those reactors are directly calling these runners. And the key manager is just about as dead simple as you can get. If the minion ID that has been found on the reactor on that event bus is in the minion DB file, we accept the key. Great, everybody's happy. And then that process exits. For the high state manager, there's a little bit more we want to do. I don't necessarily want to run a high state every time. Maybe this is a new salt master. Maybe it's a reincarnated salt master. And so now maybe these minions are trying to reauth with this guy. So what I do is I check to see if a high state's already been run on that minion. If one has been run, I bail. If one hasn't been run, I check because, hey, maybe one started running and it's in the middle of it. It's some super long high state. There's no reason to call it again. And then after running a high state, I set this little Sentinel file up into that directory I talked about, etc salt HA. And so now I know I've run a high state at least once. So pretty simple. So now we can compare how we did. So we said we wanted a service that would monitor a master and replace it. We have that with autoscaling. We needed a way to share this public-private key pair. Not a problem using S3. And that happens with the Bootstrap script, so once it comes up. We needed a way to handle the key management. This awesome program does it. The minions have to know how to find the masters. Not really a big deal. And the salt tree and the state tree, and the pillars have to be kept in sync. So not really a big deal. We can use GitFS or something similar. So I like this solution in that it just replaces itself and it works pretty well. But it's not exactly HA. And one of the problems you could have is that when you bring up a salt master and let's say you install everything from scratch, which is exactly what this is doing today, it can take like 9 minutes or 10 minutes. And some things could fail, right? Like if you're installing a package, well, maybe it's going to fail on you. So there's a couple of issues that could arise. I don't really love that, but I really like kind of where this is going. So let's improve it a little bit. So that was solution 1, if you didn't catch that. So solution 2 is, let's just use 2 salt masters. The one was, hey, I'm going to replace myself if I die, and I'm going to become the same guy I was yesterday. The new one is, let's use 2 salt masters, because 2 is better than 1. The use case really here is some geographic separation, or if you don't want any downtime while some minions may be trying to send events to masters, this is a way to kind of catch that and not have to deal with that issue. So I'm not doing this in like a hot, cold, or a primary, secondary way. I want to know that if a master fails, let's say just a master fails for some reason, I can still control everything on all the minions. So I'm not going to do something crazy, trying to, decide, well, it's only master A right now. Now it's master B. Again, I don't want any human intervention. I want this thing to just work. Okay, so what changes do we have to make if we want to do this? And the one salt master worked kind of easily. So maybe we can just iterate on this and go a little further. So what we could do is we could just add another autoscaling group and have another set number of served salt masters as 1, and just put it in a different availability zone. If we do that, before we had 1 SQSQ, so now we really want the master to get the same messages as the other master, so we'll add an additional SQSQ and just make it an additional endpoint to SNS. There's one thing that's a little funny, which is these high state runs. So now we've got 2 salt masters and they both want to do the same stuff. And we don't really want to have this weird race condition, so we need to handle that. And now the minion config has to get updated. So now, before we had, I think sol1 -salt1 as the DNS names. Now it'll be solution 2, salt1, and salt2. So we need to change that into a little YAML list in the master config and up that. So here's a nice picture, since those are nice words. You can see we just added an SQSQ, so there's still just 1 SNS topic. We've got our 2 salt masters. Here's a group for one and a group for the second one. They're going to go up and still use the same S3 bucket. And if you think about it, that makes a lot of sense because we still need them to share the same master, private, and public key pair, right? And that logic changed a little bit so that the first in wins. So if I'm the first salt master who runs that Bootstrap script and I come up, I want to see that doesn't exist, and I'll push up first. If not, I'll download. And so really simple logic. And Route 53 works the same way as before. So here's the good news. This isn't just a bunch of slides and talking points and hand waving. All this code is up here right now. You can download it and use it. It's all open source. If you like, send a thank you to HospitalityPulse. They were really generous in letting me just push this into the community. And I highly encourage you to check it out. Again, this is very much in development. So this works today. And this is what I'm moving forward with. But you know, it's still a prototype. So some of this code is ugly. Some of the logging is weird. Maybe there's some bug that I haven't encountered yet. I don't know. If you want to use it, essentially there's 2 solution set instructions for solution 1 or solution 2. And there's CloudFormation templates. And I'll go into a little bit of that in the lessons learned. So sometimes CloudFormation fails, and that really is not fun. Luckily, it's sort of a do it once and do it manually. So, okay, that's not so bad. But I had some very weird messages that I spent an hour trying to figure out, and then Amazon just worked again. So if that happens to you, don't be surprised. It only happened once in like 6 weeks of doing a lot of development. I separated out my CloudFormation templates into 2 sets of templates. And I did this because there are certain things in Amazon which really are expected to have a global namespace or to exist for a long time, like S3 buckets. So you want to be able to count on these things when you spin up your infrastructure. And I didn't really want to keep having issues or maybe having issues and whatnot. So I separated these into 2. So there are things that like I need to have, like SQSQs, S3 buckets, my Route 53 DNS, and then there are things that kind of go away. Things kind of happen to be more expensive, like servers and VPCs and things like that. And that's the second set of CloudFormation templates. So each solution has 2 CloudFormation templates. And the way you set this up is you run the first one. Obviously, you need to change some things so you don't try to get the same bucket name that I have, some things like that. And then the outputs of that, you would either pass as parameters to the second CloudFormation template, or you change the default values if you're lazy like me, and be able to just launch the CloudFormation templates, the second one, and then all the default values would be used. This point is kind of interesting. Using pre-baked AMIs would probably save a lot of time and possibly prevent a lot of issues. I saw a lot of weird boot times. Sometimes it was 5 minutes. Sometimes, you know, packages are getting installed and it takes 7 or 8 minutes. You're paying for that time. And if you've got a handful of servers, maybe it's not a big deal. Maybe it's not a big concern. I didn't really like that. So I think probably what I'll end up doing is pre-baking some AMIs through the same process, automating that, and then using those and the templates to launch from those. So that way, when the high state runs, it's really like a small differential. And that should save a lot of time and a lot of errors. Autoscaling groups are great, but they make using static IPs really tough. And that's why I ditched that and went with DNS, kind of my own dynamic DNS, but just updating CNAMEs. It was a whole lot easier. But I did have to run that from the Salt master. There's not a really convenient way to do that outside of that. And I need this whole thing to happen by itself. And I don't have any other way to really know when that Salt master sort of was born, other than the Salt master knows he was just born. So I would also, anything that you add, subtract, want to suggest, keep all the components as self-contained, as simple as possible. There's a lot of moving parts of this, and it can be difficult. One thing I'm sure it's going to come up, why didn't I use this technology? Well, I really considered a lot of different things. S3FS fused looked interesting, but I was kind of worried about race conditions. At first I thought, hey, maybe I'll just have the whole, salt tree and everything in S3, including all the minion keys and the master keys and everything. I got kind of scared, and there were some issues with installing, and I said, Salt's really made to act independently at this point. I don't think I want to go trying to do things away from that. GlusterFS I really like. I use this actually in production. now, but I don't have a way for it to self-repair when one server dies. And I need that in this scenario with our requirements. DRBD and pacemaker, way too much work, and it's sort of like having an active-active pair is difficult. And I thought about reusing EBS storage for mount points, and then I thought about it again and decided it gets kind of messy sort of quickly, and then you can have space issues, and did I really want to deal with that? And the answer was no. So as I said, this is an iterative product or project right now, and the lessons I've learned lead me to possibly solution 3, which is taking what was a minion DB file that would be pushed into S3 by both of these saltmasters and moving that information into DynamoDB. And then using optimistic concurrency for blocking, or for not blocking, but who gets to do things. And that's really the big thing. I might be able to do some other interesting things with that in terms of still utilizing the scheduler in Salt. I don't know, I haven't really explored that, but there are a lot of issues, because now there's 2 event buses and there's other stuff to deal with. So I need some kind of spot where I can put information and deal with that, and these guys can kind of coordinate. I might even be able to make the minions dynamic. I just realized there was one thing I didn't talk about, which was how I handled the race condition for the saltmasters running the high state. So if you've got 2 saltmasters, what I do is I just extended the logic a little bit further. First, they see if a saltmaster has run a high state. It's just checking for a file. Next, they use saltutil to see is high state running. Okay, that's easy. Now you enter the race condition part. Previously, we'd just say run the high state and then write that Sentinel file. So what I do is I cheat, because cheating, it's easy. So I use a salt module to append a file, and they both try to append the same file at the same time. And I do this because I don't really care who writes first initially. But then the second call, so these are synchronous calls, the second call reads the first line of the file. And if it matches my name as a saltmaster, I won. And so now I run the high state, and then I write the Sentinel file. So it's totally cheating. It's totally, maybe there's a bug in it somewhere, but it works. I ran a bunch of scenarios with it, and I was really happy with it. So that's the end of my talk, and I'm open for questions, and I can, everybody can go through the code and see things, but I hope you guys found this useful. I spent a lot of time just putting this into place. So hopefully other people can enjoy it, and we can take it to the next step from EC2 Autoscale Reactor forward. Yes?
Quick question for you. So two questions, one and a follow-up. Do you use the salt mine feature?
No, I don't.
Okay, then the follow-up question was, there's a scenario where if you're using the salt mine in a multi-master mode, when a minion goes and updates the mine, it only updates it to one master.
Sure.
So which means the other minions who might be interacting with either one of the masters, they may only get half the mine information. I'm told that that's supposed to be fixed. I don't know if there's a salt engineer here who knows if that's fixed.
You know what? I just remembered I was supposed to repeat that question. So the question, I think for the recording more than, I think everybody heard your question, but the question is, do I use the salt mine? And if I do, how do I handle the issue with certain information going into one master versus the other? I think something like that. And the answer is no. Salt mine is pretty cool stuff. I don't actually use it, but I've read the docs on it. It sounds really nice. I think it would probably fall apart pretty quickly with this. So that's why I didn't do it. Yes?
Okay, so the question for you is, minion comes up,
Yep.
and it needs to reach the master. But there's 2 masters. How does it know which one to go to?
In its config file, it actually has a list. So you're talking about solution 2, where there's, sorry, I forgot to repeat the question. So the question is, when a new minion comes up, how does he know which salt master to connect to? And so this is solution 2, where you have 2 salt masters. The answer is, he's going to connect to both. And that's exactly what we want. And the reason he's going to connect to both, in that salt minion config file, we have entries for the multi-master that says connect to master 1 and master 2. And both of them are going to manage the key management themselves for that guy.
Now, if that's the case, that's new. Because it used to be that it only connected to one. It basically, I think that somebody mentioned there may have been a peak test, try to connect to the one that responded first, and then it would do business with
So, okay, the comment is maybe this is a new problem, or this is new functionality, but I did do testing, and I was able to control and do everything from both Salt masters. And so I was pretty happy. This is 2014.7, and I'm sure that a bunch of things got fixed. I did find some issues, however, with 0MQ, especially when you cycle the Salt masters. Like, I just terminate them because I need them to die on command. And I found that sometimes 0MQ doesn't, running from the Salt minion, still thinks it's connected to the master that died. And remember, we update the DNS name. So I actually just wrote a little cron job that says every couple minutes, just restart the Salt minion. So,
Should have hopefully been fixed in 15.2.
it might be. I did talk about this issue with Mike Place and also Tom Hatch.
I think this is the same issue as the 45054 being not.
Yeah. Yeah, I think a lot of this has to do with 0MQ and TCP issues. So I don't know if you guys, you probably do know, but this rate stuff, I think is going to kind of obviate the need for a lot of these little issues and finding a way to solve them. But I think, you know, supposedly we can use it now. I haven't used it yet. I tried to set it up. There's issues with the libsodium not having native packages on Ubuntu. So I kind of said, well, I'm not going to put this in the presentation. I was trying it last night. So I said, well, okay, I'll wait. Yeah.
Do you have any experience with reactors and multi-master? Because I was trying to use reactors with multi-master and it doesn't work very well.
Okay, so the question is, do I have experience with reactors and multi-master? Well, other than the reactors here, I've only written some basic ones that were really used to add minions to monitoring systems, and it wasn't multi-master. In this scenario, the minions connected to both event buses on both the masters, and you know, it's the key, the auth event for the key, and then saying kind of like, I'm ready. And I didn't have any issues with those. So I was pretty happy with that. But I think you bring up a really good point, which is, okay, this is great for getting these minions up and going, but let's say I'm trying to do something more complicated with a real big event system, like with the new engines or machines, I forget what they're calling it, but same kind of thing. I think there's a lot of work, and it's kind of a hard problem. It's a big concurrency problem. That's also why I'm kind of hinting at DynamoDB. I'm not sure when, so SaltStack has this new technology coming out called, I think it's Salt Master Cluster or Cluster Master or something, but I didn't get the impression that it's coming out soon. So I need the solution like next week, another week. I mean, I need to iterate on this quickly because I've got a big load of traffic coming in about 60, 70 days. So I don't have time to wait for that, and I'm kind of hinting that I'll use DynamoDB maybe to do some of these concurrency issues, and maybe just some of these Salt jobs that I would have put in the scheduler local, I can just have those guys go check DynamoDB and kind of a whoever gets it first wins sort of thing, but marking it with optimistic concurrency, and this way all the minions will run, and there might be some other issues, but that's kind of where I'm headed right now. Personally, I would love to have the multi-cluster master thing working. I think it'd be great. Solve a lot of problems. Yeah, but this works today. So, and again, the code, use it. Please contribute back if you add, do something cool. I've never really run any kind of open source thing at all. This is my first trying to really offer something up. So, be gentle with comments and whatnot, please. Okay.